Okay, 5.2, we're going to look at properties of quadratic functions in that standard form. Remember, standard form is f of x equals a x minus h quantity squared plus k. So that's our standard form. Going to look at what we did in the previous lesson with our parent function, y equals x squared. And that's our blue parabola going up. The reflecting across the y axis, if we were reflected across the y, would end up in exactly the same thing. As you can see, if we substitute a negative x in place of x and square it, we still end up with x squared. Okay, so this does show us that we do have what is called symmetry, and it's where we can put a line through the graph and it's the same on both sides. The axis of symmetry is that line that divides the parabola into those two congruent halves. It is going to go through the vertex of the parabola. So, if I look at this graph of just some function a x minus h quantity squared plus k, and I draw the axis of symmetry, which is that line that divided right in half, goes through the vertex. The vertex is hk, then that line would be x equals h, whatever the x coordinate is of the vertex. So let's look at a function. I can see, if I rewrite this as x minus negative 2 quantity squared minus 3, my vertex would be negative 2, negative 3, and the axis of symmetry is whatever that x coordinate is, x equals negative 2. You try the next one. Just identify the axis of symmetry. Hopefully you're able to identify the vertex at 3, 1. The axis of symmetry then is that x equals whatever the x coordinate is of the vertex. So the axis of symmetry would be x equals 3. Standard form is when we have everything multiplied out. It is indicated here as ax squared plus bx plus c, and again, a does not equal 0, so we do have that x squared term. This is just going through the expansion, showing you what each of the coefficients a, b, and c can represent once you've multiplied them out. So you can see a is a, it stays a, but that coefficient in front of the x is actually a negative 2ah, and the constant c is this ah squared plus k. I don't expect you to remember that. However, when we do get to finding h from standard form, it does come in handy for finding the axis of symmetry. So let's look at that. So when we're in standard form, ax squared plus bx plus c. And we want to find the axis of symmetry from standard form. This is a key thing to note, again, that b equals negative 2ah, so that you can solve for h and get negative b over 2a. So when you're in standard form and you're trying to find the axis of symmetry or the x value coordinate of the vertex, you want negative b over 2a. To find the y value then of the vertex from standard form, you would just substitute that negative b over 2a back into the function and solve. And the interesting note is that the y-intercept of the graph is the constant. So what is the connection between the value of h and the equation of the axis of symmetry? The axis of symmetry is going to be x equals h. And remember, standard form, if you write it, it will become habit. It's the opposite of b over 2a. All right, so let's look at a couple examples. Standard form, determine whether the graph opens up or down. Remember, that's your A. So this is, A is positive, so it's upward. Axis of symmetry, it's going to be x equals the opposite of b over 2a. So that's opposite of b, which is negative 4 over 2 times 1, which is positive now. 4 divided by 2 is 2. Find the vertex. Well, first off, then I have to find the y-coordinate to the x, so this would be 2 squared minus 4 times 2 plus 6. 4 minus 8 plus 6, which equals negative 4, 2. So the vertex is 2, 2. The y-intercept is c, which is 6. Writing that as an ordered pair has an x-coordinate of 0. And we graph. So what you can do is just graph those critical points, which is the vertex at 2, 2. The y-intercept at 0, 6. And you know it has symmetry right there, so that means I can plot the same point on this side, so it should look like so. Now, to confirm all this, certainly you can put that in Desmos, but not being able to show the work isn't going to help you on a test. So you can always use Desmos to confirm. So try the next one on your own and then come back and check it. Hopefully you followed all of that. Substituting in that axis of symmetry coordinate for x, it's -1.5. It's approximately right through there. -1.5, 6 is here. 0, -3. So that should be there. At -3, -3, and opens down. Okay, how do you find the y-coordinate of the vertex of the parabola? You substitute whatever negative BO2a into the function. So you still have 2 more examples. I'll do the first one since I was kind of making you do the last example by yourself. I'll do this first one and then you've got the second one. So first thing you're going to do, determine whether the graph opens upward or downward. So that's your A value. A is negative, so it's downward. Axis is symmetry. Is x equals the opposite of b, which is over 2a. So it's -1. The vertex, so I have to put -1 back into the function. One squared is 1, so it's -2 plus 4, which is 2. So the vertex is -1, 2. And the y-intercept, c equals 0. So the y-intercept is 0, 0. And then we graph. So how do you graph? You just graph those points. -1, 2. -1, 2. Y-intercept of 0, 0. This is your axis of symmetry, so you should put that going down through the middle. And that means I have the identical point on this other side, and it opens down. You try the next one by yourself. Push pause, then play and check your answer. You will find that this one's going to be a little bit more complicated to graph, so because of the fractions, but you can still find those points. 0, -1. The vertex approximately -1.5 at -13/14. 13/4, sorry, is 3 1/4, right? So you can approximate that. So -1.5, -3 1/4. There's your axis of symmetry going through that. And I need a point over here. Approximately. And that's the end of day 1.